Okie dokie. One thing more about this definition. We have some notation here. Okay, we call S T inverse. So copy that into your notes. We're just going to leave this linear here. Okay, pause and copy theorem 9 in this example. Okay, pause and copy, pause and copy. Okay, theorem 9, perhaps not surprising, is if you have a matrix transformation and you would like to invert it, then you get this as your inverse transformation. Okay, you just inverse the corresponding matrix if possible. If with two F's, that means if and only if. I can't remember if I've used this or not, but there you have it. Okay, the example. T inverse of this column here. Well, and we say do it by inspection. Okay, do it by just looking at it and thinking, but not doing any excessive calculation. Okay, so how do we do that? Well, we got to remember what is a standard. What is a standard matrix? Well, okay, so this is maybe a bit more calculation than, or a bit more writing than you need, but just remember that. Okay, this is the definition of a standard matrix. Gives me this equation. Okay, therefore, T of E2 is this negative 8, 7, and therefore E2 is equal to T inverse negative 8, 7, and E2 is this vector 0, 1. So there's my answer right there. Okay, so I didn't go calculating. I didn't go try to find A inverse, I just tried to go about it a bit more cleverly, just understanding what a standard matrix is and going from there. Next. Now in part B, I want to find a formula. So what was A again? It's negative 8, 7 as my second column, and then 6 minus 5 is the first. So I'm going to invert that, right? A minus 1 is 1 over 42 minus 40 is 2. And the 7 and the 6 switch, and then the other diagonal changes sign. So my formula for the inverse is just the inverse matrix. I'll leave the half out front. It's easier to calculate in that way. And there's my formula. No problemo.